relation here, we discuss about relation between uh, potential energy and conservative force in this lecture, and then power. So now already we have discussed this important point. Change in potential energy is equal to minus of
Yes, sir.
negative of.
Conservative.
Conservative
Double.
force.
I,
Double.
I'll just try to relate this a bit better. Just for small change in potential energy is equal to
The minus.
work done by conservative force.
Yes, sir.
dWc can be as minus force conservative force dx. If it is force is unidirectional. Unidirectional means one direction force.
Okay.
Or otherwise minus fx dot dx. Otherwise minus f dot dr. Okay.
Yes, sir.
Yes, sir.
If you take this formula, du is equal to minus fx dx. That implies minus du by dx is equal to force or not.
Force. Yes,
Yes,
sir.
sir.
This is another important formula, 5-star formula. Conservative force, if you want to find out if potential energy function is given, if you find out minus du by dx, then you will get that force. This formula sometimes be written like this. F is equal to minus del u by del r. That is like F is equal to. Do you know partial differentiation? If it is r means what?
Mm.
It is only one direction. If there is three-dimensional force, so you need to do what? Partial differentiation. In mathematics, you might
Okay.
have written about this. Varun,
Yes, sir.
Yes, sir. Partial difference.
minus dou u by dou x I cap. That is u I am differentiating with respect to y z. Minus dou u by
Okay.
Yes, sir.
j cap plus minus dou u by dou z k cap. Entirely like this, you can say minus of dou u by dou x I cap plus dou u by dou y j cap plus dou u by dou z k cap. You got this? This is another very important concept. In future also you'll find out in electrostatics similarly. And problems are asked on electrostatics and also in this topic regarding with respect to this concept. U is a function
Okay.
given in XYZ. Then they'll ask what is that conservative force? What do you need to do? You need to differentiate with respect to X into I cap, Y into J cap, differentiate with respect to Y into J cap, differentiate with respect to Z and into K cap, and whole minus. If you keep, you will get the what conservative force. You got it?
Yes, sir.
Yes, sir.
Similarly, you see, we have studied about potential energy is what? K by 2 x square in a spring if it is extended by x,
Yes, sir.
isn't it? This we have derived, right?
Yes, sir.
Now you see, uh, du by dx is what? If we differentiate with respect to x, 2k
du by
x by 2 or
2 x by 2. Yes, sir.
so
Okay.
force is equal to what? Minus du by dx, right?
Yes, sir.
You got c minus kx.
Yes, sir.
So this is a sample. If you know the potential energy equation, then you can get the force equation.
Okay. Yes, sir.
Relation between potential energy and conservative force. This is a very important result. This is the most valuable, one of the most valuable concepts in this topic.
Okay.
Let us see if we can solve. Meanwhile, first you study the concept, then I will show you the This can. Now, coming to the next part, we discussed about this potential energy and force. Then the thing is equilibrium analysis.
Okay.
What is for a particle to be in equilibrium? The net force should be what?
0.
0. And this
Zero.
0 means what? Minus du by dx should be equal to what? 0.
0.
Du by dx should be equal to 0. So there are three kinds of equilibrium in this force equal to 0 situation.
Okay.
Do you remember? One is
Yes.
Static is okay. Oh.
stable equilibrium, force 0, and other is unstable equilibrium,
Neutral equilibrium.
and other is neutral equilibrium. What here also force 0, here also force 0, here also force 0. But what is the difference between them? In all the three cases, du by dx is 0 only. Okay.
Okay.
Yes, sir.
What is the difference is in stable equilibrium, this you see, suppose the particle is like this here. Here it has potential energy minimum. Okay.
Okay.
Okay, sir.
It is mean position. This is the mean position. So if we displace it to a distance, some bit of angle, and then you leave it, it will again try to come back to its normal position or not?
Yes, sir.
Original position, original mean position.
Yes, sir.
Yes,
That
sir.
is why it is called as.
Stable equilibrium.
Stable equilibrium.
But you see here, suppose in the situation, you keep the ball, here force is 0, here also it is at rest, here also it is at rest. Okay.
Yes, sir.
Yes, sir.
Now you leave it. What happens?
It may fall this side also, that side also.
You just displace it by a small angle, then you see the ball will try to go away from this mean position, right?
Yes, sir.
So here it is called as unstable equilibrium. Here the potential energy is maximum.
Max.
Okay. Then here it
Yes,
is
sir.
maximum. Here neutral equilibrium is like this. Suppose if you displace the ball, neither it will go away or neither it will come. Here also force 0, here also force 0. Neither it will go away from the original position or neither it will come close to the original position. This is called as
Oh,
Neutral equilibrium.
okay. Now, if you draw a potential energy graph and X graph, so if you draw here, the potential energy is minimum and force is 0. Du by dx is 0 is what? The slope or not?
yes, sir.
Yes, sir.
Du by dx is nothing but slope of this graph or not? From your mathematics knowledge.
Yes, sir.
Here the slope
Yes, sir.
graph becomes 0
Yes,
or not? Here.
Yes, sir.
At maximum,
Yes, sir.
minimum slope will become 0 or not?
Yes, sir. Yes, sir.
Yes, sir.
But here potential energy is minimum. So this is called as stable equilibrium.
Okay.
This is unstable equilibrium. That means this point x1, x2, this is x3. So here it is neutral equilibrium. X1 is stable equilibrium. Did you understand the concept?
Yes,
Yes, sir.
sir.
X2 is unstable equilibrium. And X3 is neutral equilibrium. The graph is given and he is asking you to find out. At x1 potential energy is minimum for stable. Here potential energy is maximum unstable. Here potential energy is equal to constant. Okay, neutral equilibrium.
Yes, sir.
Yes, sir.
how to find out if function is given, graph is given. I have taught you how to solve it. Okay. If function
Yes, sir.
is given, how will you find out? We know that potential energy is minimum for stable equilibrium, right?
Mm,
Yes, sir.
Yes, sir.
First condition is it should become equilibrium. That means what? Du by dx should be equal to
0.
0. Second condition is for stable to become for it to become stable equilibrium, potential energy should be minimum.
Yes, sir.
Potential
Yes, sir.
is minimum means what? For a given function, suppose u is equal to some f of x. For it to be minimum, value, for how to find the minimum value, maximum minimum value?
Differentiate and then equate it to 0.
So differentiate and equate it to 0 we have done. Force is 0. But here
Okay.
for minimum value, differentiate d to u by
Okay. Yes, sir.
what? For minimum,
Oh, minimum maxima. Yes, sir. Yes, sir.
for
We
minimum
need to differentiate.
0.
Yes, sir.
Varun, do you know this concept?
Yes, sir. Yes, sir. Yeah, yes, sir. First year concept, sir.
So for minimum y, I'll just try to. Do you know why it is greater than 0?
Yes, sir.
Yes, sir.
Why?
1 minute, sir.
So for stable equilibrium,
It is greater.
du by dx is.
Sir?
Huh?
No, sir. What you are telling, I did not understand, sir.
Du by dx is equal to 0. We need to do first for finding out some values, maxima or minima. And if you want to know whether
Yes, sir.
stable or unstable, you need to check double differentiative.
Ah, yes, sir. D square u by
Greater
dx
than
square
0
is greater
minimum.
than 0.
Greater than 0 minimum.
Less, less than 0 maxima.
Nice.
Maximum. So this is stable. This is
Unstable.
Unstable.
actually why it is, in mathematics. I'll just try to tell you here. Suppose minimum looks like
Okay.
minimum looks like this, right? The curve here.
Yes, sir.
So here you see the slope at d2u by dx2 is rate of slope, right? It's differentiation of
Yes, sir.
Yes, sir.
it's a if you differentiate u with respect to x, that is first derivative. If you
Okay.
if you differentiate that first derivative with respect to x, then that is second derivative, right?
Yes,
Yes,
sir.
sir.
That is, this is nothing but slope.
Yes, sir.
This one. This is nothing.
Yes, sir.
This is rate of change of slope. Got it?
Okay.
You
Okay,
see,
sir.
at this point, just before point, how the slope is there, like this. Just before
Yes, sir.
minimum. Just after point, you see, like this. Are you getting? No.
Yes, sir.
Understood, sir.
Now this is a positive slope. This is a negative slope. Why negative? You see here.
Yes, sir.
This is
Yes, sir. It is in the left side of the graph.
so you see here, rate of change of slope matlab final slope minus initial slope by this is change in x, that is x2 minus x1. Okay, that is
Yes, sir.
Yes, sir.
final slope is positive minus initial slope is negative. That means minus minus positive or not.
Yes, sir.
X2 minus x1 is positive because x2 is bigger one and x1 is smaller one. Okay,
Yes, sir.
now you see what
Yes, sir.
positive value or not.
Yes, sir.
Yes, sir.
That is for minimum, double differentiative is greater than 0. I think you might not have studied like this, as far as I know.
Yes.
Now,
We studied it something, but I just remember it. Just I remember that greater than and lesser than part, sir.
now you understood why it is positive for minimum. Double.
Minimum.
Yes,
Yes,
sir.
sir.
You see maximum here. You see maximum just before that our required value. You try to find out the slope. That will be like this, positive.
Yes, sir.
Just after point, that will be like this, approximately. This is negative.
Yes, sir.
Negative slope, right?
Yes,
Yes,
sir.
sir.
Rate of change of slope means what? Negative slope minus positive slope divided by x2 minus x1, that small dx. Do you see negative minus positive? This is entirely negative or not?
Yes, sir.
That is why the value is what here?
Negative.
Maximum. For maximum,
Yes, sir.
the rate of change of slope is negative. For minimum, the rate of change of slope is positive.
Positive.
For maximum,
Yes, sir.
Varun, 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 you understood this? Varun,
Sir.
you understood this concept? For maximum, the rate of
Yes, sir.
slope is negative. From
Change
positive
of slope.
to negative. For minimum, the rate of change of slope is positive.
Positive.
So that is why for stable equilibrium should be potential minimum. That is rate of change of slope is positive. Unstable equilibrium, the potential energy is maximum. That is rate of change of slope is negative. And these are the important points to be considered
Negative.
for taking stable or unstable equilibrium. Okay.
Yes,
Okay,
sir.
sir.
So now the equilibrium concept is over. You need to solve some problems. That's it. So next,
Yes, sir.
let's try to solve some previous questions
Sir, I have some doubts, sir. Can I ask you?
in this topic.
No, sir.
Wait for.
Work power energy only. But
We'll discuss. We'll discuss. Wait. Let this lecture be complete. Question here. Given potential energy is equal to x cube by 3 minus 5x square plus 6x plus 3. Okay.
okay.
Find force. Question is find that conservative force. Force is what? Next, question A. Question B is find points of equilibrium. Then find points of stable equilibrium and unstable equilibrium. You got the question?
Yes, sir.
Yes, sir.
Try to find it out.
You sent something, sir?
First you solve this question, then we'll solve that question.
Okay. Done, sir.
You solved it. What is the answer? What is
For the first one it is 10x minus x square minus 6.
10x minus x square?
X square minus 6.
Okay. How did you do? Du by minus du by dx.
Minus du by dx.
Dx square by 3 minus 10
Minus 10 plus 6.
plus 6. If you multiply with minus, what will we get? Minus x square plus 10x
Plus 10
minus 6.
Yes, sir. This is what I got.
This is the force. Okay. That is okay. Then
Second one is 10 plus or minus root 76 by 2.
minus 10, sorry, x
10
square. Okay, okay. 10 plus or minus
plus
root over b
root
square.
76.
B square is how much? 100 minus 4 into minus 1. Okay, this is plus again. Minus 4, 6 is 24. Okay. Answer is 2 into minus 1. Okay. How much is the answer? 10 plus or minus root over 76.
76
By
by
minus,
minus 2.
by minus 2 means you can multiply with
Yes, sir.
minus. So here, this question has become little complicated. You take only A and B. Okay.
Okay.
So
Yes,
if
sir.
you want to find out points of stable and unstable equilibrium, you need to double differentiate it and supply this.
Yes, sir. I did.
You got the answer also?
I got 5 for the first one, sir.
Okay.
Stable.
Second one, second root.
My doubt is, sir, because it is 0 anyway, like whatever be the sign, the answer will be 5 only, sir. That's why I did not do. Maybe I might be wrong. That's why I did not do, sir.
No, you got the roots right. This is one root. Minus 10 plus
Yes.
plus sorry, minus 10 minus root 76 by 2 is one root, and
Minus
minus 10 minus plus root 76 by 2 is one another root.
yes, sir.
So what do we need to do? Varun, are you understanding?
Yes, sir.
So these two roots have come. You have to substitute these two roots in double differentiative. You take double, you do the double differentiative.
Okay, yes, sir. Yes, sir. Yes.
So minus 4x
Yes, sir.
plus 10 is the answer.
Yes, sir.
So you substitute which is becoming positive, you see, and which is becoming negative, you see. For one root, it will become positive.
One root will become negative. Yes, sir. Yes, sir. I understand.
Then the values is whichever it is coming positive, that is stable equilibrium. Whichever it is coming negative, that is unstable equilibrium. Okay.
Yes.
This is the way we need to solve the problem.
Okay.
Then I have sent you a problem, right? After solving this, you understood the process, Varun?
Yes, sir.
Yes,
There
sir.
will be similar
Yes, sir.
problems in your material regarding equilibrium points. Then you need to solve those questions.
Yes.
Then
Yes, sir.
I have sent you a question, you see. Given
Yes, sir.
electric potential at a point xyz is given by V is equal to minus x square by
Minus
minus xz cube plus 4 This is in electrostatics topic. Electric field
Yes,
is
sir.
asked. Electric field. If there is a relation between potential and field, potential energy and force. Okay.
Yes, sir. V is equal to ED, I guess.
You see, no. That is for constant electric field, not here. U is equal to, suppose f of x is given. My force is how much? Minus du by dx, right?
Yes, sir.
Otherwise minus
Yes, sir.
del u by del r.
Yes, sir.
That is partial differentiation.
Yes, sir.
Like that, if potential is given, electric field is equal to, that is field, gravitational field or electric field is equal to minus del v by del r. Did you get this point?
Yes, sir.
Like force is related to energy, potential energy.
Yes, sir.
Potential is related to electric field or any gravitational field or any conservative field. Okay.
Okay.
So now potential is given.
Yes,
How
sir.
to get electric field? That is nothing but minus
Differential.
del v by del r. Delta v by delta r. That is nothing but partial
Yes, sir.
differentiation. How much? What is the function I gave here? What do we need to do? Minus of dou u by dou x I cap. Are you getting whatever I am teaching now?
Yes,
sir.
sir.
Dou u by dou u by dou by j cap. Dou u by dou z k cap. This will give you electric field. Suppose if it is potential energy, then it will give you electric force there.
Okay.
Yes, sir.
So that is why you see F is equal to EQ. U is equal to VQ. You might have studied these formulas.
Yes, sir.
E is equal to F by Q. V is equal to U by Q. U and V are related and V and E are related. Okay.
Okay.
Yes, sir.
In physics, this is the beauty. One thing you learn, other things automatically will come to you.
Yes, sir.
Yes, sir.
You see here. What is the question here I gave? V is equal to minus x square y. So you can solve it or not? X square y. Differentiate.
Yes,
sir.
You can solve it, sir.
Solve it.
Differential.
V is equal
Comparing with the
minus x square y minus xz cube plus 4. Differentiate with respect to x. If I differentiate with respect
yes,
to
sir.
x, y should be constant. Partial.
Yes, sir.
differentiation. So what will be the answer?
Yes, sir.
Minus 2x y
Y by dx.
minus z
Minus
cube.
Z cube.
Okay. Plus 0
Yes, sir.
Yes, sir.
into I cap. Finally, I'll keep minus for everything later on. Plus
Okay.
with respect to y, if you differentiate, what will happen? Minus x,
Minus x square.
x square.
Minus x square.
Minus xz cube.
That is
J
0.
No,
That is 0. With
that
respect
is
to
0.
y.
Yes, sir.
This is 0.
Yes,
Okay.
sir.
That into j cap
Yes, sir.
plus this 0 with respect to z. Minus x.
Okay.
No, sorry. Minus x.
Minus 3xz.
Minus
Minus
3x square into k cap. Okay.
Okay.
So if you multiply
Yes, sir.
all with minus, what will happen? Z cube plus 2xy into I cap plus x square j cap plus 3xz square k cap.
Okay.
You check
K
the
cap.
answer where it is present here.
Okay.
Yes,
In
sir.
the options, what is the option here in the option?
D, sir.
Option
Option.
D.
Option.
D. So answer 41st question. Option is what? D. D is the correct answer. You got it?
Yes, sir.
So that
Yes,
question
sir. I got it.
is given in electrostatics, but that is actually linked to work per energy. The same concept will be repeated in electrostatics and the same concept will be repeated in gravitation also. If I can,
Okay, sir.
where gravitational field is
Yes, sir.
there, gravitational field, potential and gravitational field, both are related. Where gravitational potential energy and
Yes.
gravitational force, both are related with the same
Yes,
relationship.
sir.
What is the relation here? F is equal to minus del
Minus
u by del r.
del R.
Yeah.
E is equal to minus del v by del r.
Del R.
Partial differentiation ones. And another thing, F is equal to EQ. That is, E is equal to force per unit charge. Like this. V is equal to, U is equal to VQ. That is, potential energy is equal to potential energy per unit charge. Okay.
Okay.
Both are related like this.
Yes, sir.
Yes, sir.
Similarly, you need to remember these formulas. Gravitational field E is equal to force by mass, force per unit mass. Gravitational potential is equal to potential energy by unit mass.
Mm,
In gravitational field,
yes, sir.
electric field and electric potential per unit charge is there. In gravitational field and gravitational potential per unit mass will be there. This is a
Yes, sir.
5-star concept you need to understand because you have already studied 2 years of syllabus. To most extent. That is why I taught you this thing here itself.
Yes, sir.
So I'll send you another link and we'll discuss in the another part of the class. Okay.
Okay.
Okay, sir.